All right, guys, this is going to be the last video for this chapter 9 notes. Again, we're looking at the second type of significance test, which is about means. So before we did it for proportions, now we're doing it for means. And again, the key is just looking at here. So we're looking at means. This is the type of problem that we're looking at. Looking at means versus proportions. So again, if you ever read the problem and you see something about percentages, then you're going to do proportions. If you're looking at something about averages and means, then you're looking at this. So what are the conditions that we need to look for? So number one, again, randomization. Again, that goes back to the whole, can we extrapolate to the population? Large counts. N needs to be less than or equal to 1/10 big N. And number three, the population is normal. We talked about a couple different things here for normality, right? We talked about central limit theorem. So if population is not normal, then need large sample, right? CLT. It's kind of about here. So here, the test statistic that we're going to use, again, a reminder, we have statistic minus parameter divided by standard deviation of statistic. And so here we're going to have t, we talked about the t distribution already, is equal to x bar minus mu. So statistic minus parameter divided by standard deviation statistic, which is sx over the square root of n. So what is the t distribution? It's another bell-shaped distribution. So the shape is symmetrical and unimodal. The center is at 0. The spread is greater than the z. And the last big point, as n increases, the t distribution approaches the z distribution. So as n gets larger and larger and larger, your t distribution ends up becoming more and more like the z. Here, again, last thing, population, standard deviation is typically unknown. Therefore, we use standard error, which is also known as the standard deviation of sample. All right. So how do you calculate p-values from the t distribution? You'll use a t-table, which is on Canvas. It's one of the formula sheets they give you. So you will use a t-table, or the formal name known as students t distribution. Okay. And if you look in this table, and we'll look at this in detail in class, it has this thing called DF, which stands for degrees of freedom, which is equal to n minus 1. Okay. And if you look in the table on Canvas, you notice that I think it is the first 40, and then it starts skipping by 20. And so you want to always go to the lower degrees of freedom. Okay. So if you're in between, go to the lower one. So calculate the test statistic. In the example below, I'll do this one real quick. So here we're going to have t equals x bar, which is 9.7 in the problem, minus mu, which is 10, divided by standard deviation of your sample, 2.1, over the square root of n, which is 35. And this is equal to a t-value of negative 0.845. The degrees of freedom, n minus 1, is 34. 35 minus 1, 34. So you can try the next one on your own, see what you get, and we can kind of compare those. Okay. And then again, we'll do this in class together. Here we got some data. We'll look at it. So here, again, key things here. We got 24 sandwiches, so we don't have enough for central limit theorem. So we're gonna have to graph some things here. So we'll look at this in class. This is a good full example. Okay, moving on. Can you use a calculator? Yep, and we'll go through this in class again. But again, it's part of the whole menu statistics distributions, so it'll be there. So we can do that, but again, we want to set everything up, and then we can go to the calculator to do the actual calculation. Okay, another problem here that we'll do in class. You guys will work on this together. So we'll do that. Okay. Now, last thing I want to talk about in this video, paired data. What do we do when we have paired data? So if you do a completely randomized design, what you can do is you can do a 2-sample t-test. Okay. So that's if you just have, a giant list and then you kind of just break people off. But now let's say you do a matched pairs, and so now we're looking at blocks of size 2. Well, what could we do? Well, we looked at this before, but we look at the differences of the two groups. Right, with HO being that the difference is equal to the mean difference. So mu sub D is going to equal 0, right? So our null hypothesis is always representing no change. Okay. And so then what do we do if we're looking at this paired data? Well, what we're going to do is we're going to calculate. So step 1, it's going to be calculate differences. And step 2 is going to be to use 1-sample t procedures. So now we've taken our 2 and now we're just our 2 samples and just turned it into 1. So looking at 2 different groups, we're just looking at one group and just looking at their differences. And so then we can do what we've done before. And the reason why you do all this is because you increase power. Okay, so here you increase power. Okay. Better form of sampling, and therefore you can increase your power. So we'll look at the next problem together in class. We'll calculate all the differences, and then we'll do all 4 steps. Again, really good practice. That's why I don't do these videos. And then look at the last couple of things here in this video, and then we're done. So what is the difference between statistical and practical and clinical significance? So in stats, the p-value in significance test measures how likely it is to get results as extreme or more than the ones observed. The smaller the p-value, more extreme. Your alpha is your cutoff. Okay. And so the thing is that everything that we've looked at has kind of been with one sample. But in a lot of times we want to look at multiple samples. And so what you could do is you could run multiple t-tests. I know a lot of you in the IB programs or have done like multiple t-tests. The problem with that is you're going to create more error. So what's the problem running multiple t-tests or multiple tests? The more tests, the greater likelihood of creating an error. Error is compounded for additional tests. So then this is going to lead to what we call an ANOVA, which we get to at the end of the semester. And some of you, I've kind of talked to some of you about it again with your IB stuff. We've looked into this as a way of, instead of doing multiple t-tests, you can look at ANOVA, which is analysis of variance, and kind of produce some pretty cool results from that. So that's it for this video. Again, we'll do all the examples in class. As always, if you have questions, let me know. But have a great rest of your day.